So what we did is we ran those key enzymes in those 7 steps against the Brenda enzymatic database, and then used all of the known flavonoids, polyphenolics that are in not only grapefruit, but every plant. We abandoned grapefruit, as you remember, because it was too bitter. We said, well, what if compounds like this are available in other plants? And sure enough, there were. So we went from, we did this stuff at UCLA and also on a computer in Switzerland. We ran these it took us years. And we finally got down to 10,000 compounds. And then eventually we got down to a family of 10 that were the most effective at regulating these 7 steps. And then we did some animal studies on rats, and we came to a group of 3. That's myricetin, chlorogenic acid, and quercetin. Those 3 together control the 7 steps in carbohydrate metabolism. We then asked ourselves, well, why is this true? I mean, what's the issue here? Why are there flavonoids in plants that are regulating carbohydrate metabolism in mammals? So a little bit more background research, and we came to a hypothesis. And that is, plants with glucose in them, plants with a high carbohydrate load, they want you to spread their seeds. They want you to eat them. An apple wants to be eaten, so the seeds will be spread. The same thing with a citrus. So we have an issue here of coevolution, where the plants are trying to get their seeds dispersed, and they're using mammals to do it. Also in nature, sugar is a poison, like a glucoside, like Roundup. It's a poison. Some plants have a different strategy. They want you to leave them alone, and they're going to kill you. So a plant either is providing energy or it is a poison. Let me say that again, because this is really critical. Sugar is either a food source or it's a poison. So how does the body distinguish sugar on its own, glucose or fructose? How does the body know whether it's a poison or it's good for a food source? This is where the flavonoids enter into the picture. The flavonoids are a cofactor. They are a chaperone. They are a sugar.
We surmised that the body had to have some way to distinguish between sugar as a poison and sugar as a food. So this hypothesis is that plants that want you to eat them and consume them as energy provide a chaperone, which tells the body this is okay to use. Otherwise, sugar by itself is recognized as a poison. Now, where does the body put poisons? In fat tissue. This is a standard in mammals and even in like fishes. If you have any poison, any toxic poison, whether it's a heavy metal or poison, it accumulates in fat tissue because the body is just trying to sequester it there, isolate it. And this was really an eye-opener because we saw that people are consuming vast quantities of purified sugar without chaperones. So not only are they eating too much sugar, 100 times more than we did 100 years ago, not only are they consuming vast quantities of sugar, but it's a poison. The body recognizes it as a poison. And then an inflammatory response starts. That's the way the body tackles any intrusion. The first step is an inflammatory response. So we did some further research. As I said, we refined these flavonoids down to ones that would regulate carbohydrate metabolism, tell the body that this sugar is okay, and direct the sugar to where it should be. That is in muscle and brain tissue rather than just going into fat tissue. So this is in 2007, and certainly by now our hypothesis has kind of moved into a theory as we've done some further research. And now we are convinced that mammals are supposed to consume sugar along with these chaperones. It's just like discovering a new vitamin. These flavonoids are essential for normal, regular carbohydrate metabolism. And those persons that do not have enough of these flavonoids in their diet, if they're not supplemented, they are under a constant low-grade inflammation. And one of these ingredients in this formula is a superior anti-inflammatory. It reduces inflammation dramatically. It's better than any drug on the market. It's myricetin. Myricetin is the key molecule here. So we have a formula of 3 bioflavonoids that together regulate carbohydrate metabolism, and they are anti-inflammatory. So that's really the basis of the science here. We feel we have discovered a vitamin, a family of vitamins, just like the B vitamins. They are a family of vitamins. And to our surprise, back in the 40s, a similar class of compounds were nominated to be called vitamins, and they were calling them vitamin P. And because of no one followed up on it, it did not become established as a vitamin. Now, you might be familiar with the United States and Canada regulations that do not allow us to discover any new vitamins. That's the law now. Okay. If you find a compound that has some influence on a disease, it has to be regulated as a drug. The last time when these rules were put in effect, which was 1997, briefly for about a month, all our common vitamins, A, D, E, K, C, etc., they were classified as a drug, and the FDA realized that that would mean that fruits and vegetables would contain drugs, and they would be illegal to sell. So they wrote in a grandfather clause that said all our currently known vitamins and minerals that are on the books are grandfathered in. But any new molecules that are discovered that impact disease will have to be called a drug. So we're not calling this a vitamin. We're not calling it a drug. We're just telling you that the human body, the mammals, require a certain amount of these flavonoids, of these specific flavonoids, in your daily diet in order to have a normal, correct carbohydrate metabolism. Unfortunately, you cannot get enough in a healthy diet because the fruits and vegetables that we have today have very little of these compounds in them because of breeding. If you were to go back 10,000 years and look at a blueberry, a dark berry, it had a load of these flavonoids in them. Today, very little of these flavonoids and lots of sugar. Just like grapes. Grapes have become like candy. They're just water sacks of sugar with a few vitamins and just a few flavonoids. The same thing for everything. Name it. Bananas, tomatoes, pineapples, all of these things that are good for you. They've bumped up through genetic practices. They've bumped up the sugar, and the flavonoid content have been neglected. So this is the underlying concept of how this works, why it's so successful, and the underlying scientific explanation. Of course, it's still just a theory that we're working on, but once we have given this to people, we find that people that have no health issues, that they think they are normal, they're in good health. Once they take these flavonoids, they've told us they feel like they've come awake because they have been under low-grade inflammation for their whole lives. From their conception up until the present day, they have been in a low-grade chronic inflammation. And they start taking this product and they feel energized. They sleep better. All those things, I think on this call are mostly doctors. You can understand that if you're on a low-grade inflammation. Of course you don't sleep good. Of course your bowel movements are not perfect. And anything you can talk about, the exchange of oxygen and carbon dioxide, of course those are all disrupted because your body is under a constant attack. It thinks it is by a poison, which it is, and there's an inflammatory response, and your whole body is being degraded. So normal people that take this, normally healthy, they actually feel like they've woken up. They can think better, clarity of thought, better digestion, breathing is easier, sleeping is easier, you name it. If you have diabetes or pre-diabetes or metabolic syndrome, which, by the way, that was the first of that scientific paper I mentioned, was on patients with metabolic syndrome. And those persons got out of having metabolic syndrome. They were pre-diabetic. If you are diabetic or pre-diabetic, this allows your blood sugar to return to normal by regulating that carbohydrate metabolism and reducing that constant inflammation. If you're an athlete, you have more efficient carbohydrate metabolism, so you perform better. You can either perform longer on the same carbohydrate load, or you can do the same with less carbs.